Next topic is moments about origin of the Poisson distribution. In these four moments are there. First moment is denoted by the mu dash. The first moment is mu1 dash, second moment is mu2 dash, third moment is mu3 dash, fourth moment is mu4 dash. Mu1 dash is nothing but expectation of the x is the first moment. Second moment is expectation of x square is the second moment. Expectation of x cube is the third moment. Expectation of x power 4 is the fourth moment. Here, x square can be written as x square minus x plus x, like that. In this, x is taking common x minus 1 plus x. So we are split into two terms. One is x into x minus 1, another one is x. In the third moment, that x cube can be written as, first x is, we can write it as x only. The x square can be written as x square minus x plus x. We can add and subtract with x. In the first two terms, x is taking common, x into x minus 1 plus x. In the x cube can be written as x into x minus 1 into x minus 2 plus 3x into x minus 1 plus x, just like as binomial distribution. In that also, the moments can be finding from this expectation of x cube. X to the power of 4 is equal to expectation of x cube. X to the power of 4 means x to the power of 4 can be written as x into x minus 1 into x minus 2 into x minus 3 plus 6 into x minus 1, x minus 2 plus 7 into x minus 1 plus x. After the simplification of all these, we are getting the x to the power of 4. After the simplification of this x cube only, after the simplification, we are getting x square. X is like that x. But we have to remember this x to the power of 4 means x to x minus 3, 6 into x to x minus 2, 7 into x minus 1, like that. Okay. Here, we are going to discuss the first moment. First moment about the origin. First moment about origin. About origin means the first moment, it can be defined as mu1 dash is equal to expectation of x. By the definition of the Poisson distribution, we can discuss these moments in the Poisson distribution only. The definition of the Poisson distribution. We have P of x comma lambda is equal to e power minus lambda into lambda power x by x factorial for all x values from 0, 1, 2, 3, so on, 0 otherwise case. For non-negative values, the probability distribution is 0. For positive values only, we are taking the e power minus lambda into lambda power x by x factorial. Here, the first moment is mu1 dash. It is equal to expectation of x. It is equal to summation x from 0 to infinity x p of x. It is equal to summation x equal to 0 to infinity x. P of x means e power minus lambda into lambda power x by x factorial. It is equal to summation x equal to 0 to infinity x into e power minus lambda into lambda power x by x factorial can be written as x into x minus 1 factorial. X get cancelled here. The x value starts from 1 to infinity e power minus lambda into lambda power x by x minus 1 factorial. Here, put x minus 1 is equal to y. From this, x equal to y plus 1. Here, when we can take x minus 1 equal to y, again the summation can be transformed into y variable. The y variable starts with 0, 0 to infinity, e power minus lambda, power y plus 1 by y factorial. It is equal to summation y equal to 0 to infinity e power minus lambda, lambda, lambda power y by y factorial. It is equal to lambda is right outside, summation y equal to 0 to infinity e power minus lambda into lambda power y by y factorial. Here lambda power y by lambda factorial means here e power minus lambda is taking right outside. Here lambda into e power minus lambda, this is the 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus lambda cube by 3 factorial plus so on. Here the summation of infinite terms is equal to, it is the lambda into e power minus lambda into e power lambda, e power lambda, e power minus lambda get cancelled, it is equal to lambda. Therefore mu1 dash equal to lambda, lambda is equal to, what is the value of, in the Poisson distribution we are taking the product of the maximum number n and smaller value of the p. This is the first moment in the Poisson distribution. Next, to find the second moment. Second moment about origin. The second moment is nothing but we can take mu2 dash is equal to expectation of x square. That is mu2 dash is equal to summation x equal to 0 to infinity x square p of x. This x square can be written as summation x equal to 0 to infinity x into x minus 1 plus x into p of x. Write separately summation x equal to 0 to infinity x into x minus 1 into p of x plus summation x equal to 0 to infinity x p of x. Here it is equal to summation by the Poisson distribution x equal to 0 to infinity x into x minus 1, p of x means e power minus lambda into lambda power x by x factorial plus summation x equal to 0 to infinity x into p of x. Directly we can write it as lambda by the first moment. First moment is equal to summation x equal to 0 to infinity x p of x, that is equal to expectation of x is equal to lambda. So we can directly substitute the lambda value. It is equal to summation x equal to 0 to infinity x into x minus 1 into e power minus lambda, lambda power x by x into x minus 1 into x minus 2 factorial. These two are eliminated. That is nothing but 0 and 1 are eliminated. So plus lambda. The next step is x is 2 eliminated means we can start from 2 to infinity. Why? Because 1 is 0 eliminated, 1 is 1 is. Next we can start with the x from 2 to infinity and these two are cancelled. E power minus lambda, lambda power x by x minus 2 factorial plus lambda. Here again we can take x minus 2 equal to suppose y, x equal to y plus 2. So lambda power x equal to lambda power y plus 2. It is equal to lambda square into lambda power y. This is equal to summation we can transfer into y means y again starts from 0 to infinity e power minus lambda, lambda square into lambda power y by y factorial plus lambda, lambda square right outside and e power minus lambda outside. Again we can substitute the values of 0. 0 means lambda power 0 is 1 plus lambda power 1 by 1 factorial plus lambda square by 2 factorial plus so on. The second term is lambda. It is nothing but e power minus e power minus lambda, lambda square as it is. It is the expansion of e power lambda plus lambda. Why? Because we know that e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. It is the basic of the intermediate. So these two are get cancelled. We are getting the lambda square plus lambda. That is nothing but lambda into lambda plus 1 is the second moment about the origin. That is mu 2 dash is equal to lambda into lambda plus 1. The third moment. Third moment about origin. Third moment about origin means that is mu 3 dash is equal to expectation of x cube equal to summation x equal to 0 to infinity x cube p of x. The x cube can be written as mu 3 dash is equal to summation x equal to 0 to infinity. X cube can be written as x into x minus 1 into x minus 2 plus 3x into x minus 1 plus x into p of x means e power minus lambda, lambda power x by x factorial. Now we can split into three terms. X equal to 0 to infinity, x minus 1, x minus 2 into e power minus lambda, lambda power x by x factorial plus summation x equal to 0 to infinity 3x x minus 1 e power minus lambda, lambda power x by x factorial plus summation x equal to 0 to infinity x e power minus lambda, lambda power x by x factorial. It is equal to, here x factorial can be written as x into x minus 1 into x minus 2 into x minus 3 factorial. So 1, 2, 3. 1, 2, 3 eliminated. We can start from x equal to 3 to infinity e power minus lambda, lambda power x by x minus 3 factorial plus summation x equal to 0 to infinity 3. Here x factorial can be written as x into x minus 1 into x minus 2 factorial. Here 1, 2, 1, 2. So starts from 2 to infinity 3 into e power minus lambda, lambda power x by x minus 2 factorial. This is expectation of x. Here x means summation x p of x. This is the last term is the x p of x. So we can write it as lambda only. Okay. Next, we can take it as x minus 3 is equal to suppose y, then x equal to y plus 3, then lambda power x means lambda power y plus 3 is equal to lambda cube into lambda power y. So here it can be converted, transferred into another variable y from 0 to infinity e power minus lambda, lambda cube into lambda power y by y factorial plus here x minus 2 equal to z. From this x equal to z plus 2, lambda power x equal to lambda power z plus 2. It is lambda square into lambda power z. So we can write it as summation z starts from 0 to infinity, that is the transformation of the variable, 3 into e power minus lambda, it is lambda square into lambda power z by z factorial plus lambda. Here lambda cube right outside, e power minus lambda outside, then substitute 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus so on, plus 3 lambda square e power minus lambda right outside. Again expansion of this is 0 means 1, 1 power is 1, 1 factorial plus lambda square by 2 factorial plus so on, plus the last term is the lambda. This is equal to lambda cube e power minus lambda into e power lambda plus 3 lambda square e power minus lambda into e power lambda plus lambda. These two are get cancelled. We are getting lambda cube plus 3 lambda square plus lambda. This is the third moment. So we can write it as mu 3 dash is equal to lambda cube plus 3 lambda square plus lambda. It is the third moment. Next one is the fourth moment about origin. That is fourth moment means mu 4 dash is equal to expectation of x power 4, that is equal to summation x equal to 0 to infinity x to the power of 4 p of x. That x to the power of 4 can be written as summation x equal to 0 to infinity x into x minus 1 into x minus 2 into x minus 3 plus 6x into x minus 1 into x minus 2 plus 7 into x minus 1 plus x. P of x means e power minus lambda into lambda power x by x factorial. Write separately summation x equal to 0 to infinity x into x minus 1 into x minus 2 into x minus 3 e power minus lambda lambda power x by x factorial plus 6 right outside summation x equal to 0 to infinity x into x minus 1 into x minus 2 into e power minus lambda into lambda power x by x factorial plus 7 into summation x equal to 0 to infinity. Here I think x into x minus 1. X into x minus 1 e power minus lambda lambda power x by x factorial. This is the x expectation means that is lambda. Why? Because summation x e power minus lambda lambda power x by x factorial is equal to, by the first moment it is the lambda. It is equal to summation 1 0 1 2 3 starts from x equal to 4 to infinity e power minus lambda lambda power x by x minus 4 factorial plus 6 into summation 0 1 2 starts from 3 3 to infinity e power minus lambda lambda power x by x minus 3 factorial plus 7 summation x equal to 0 1 starts from 2 to infinity e power minus lambda into lambda power x by x minus 2 factorial plus lambda. Here clearly we can write it as x factorial can be written as x into x minus 1 into x minus 2 into x minus 3 into x minus 4 factorial. These four are eliminated. Same x factorial can be written as x into x minus 1 into x minus 2 into x minus 3 factorial. What we want, we can write it as up to there and factorial only. So here in this x minus 4 equal to suppose y, then x equal to y plus 4. Lambda power x is nothing but lambda power y plus 4 equal to lambda power 4 into lambda power y. It is for this. Here x minus 3 is equal to z. Then x equal to z plus 3. Lambda power x equal to lambda power z plus 3 equal to lambda cube into lambda power z. And x minus 2 equal to some cube. Here not we are taking cube. Some u. X equal to u plus 2. Lambda power x equal to lambda power u plus 2 equal to lambda square into lambda power u. Here mu 4 dash equal to e power minus lambda summation y equal to 0 to infinity lambda power y into lambda power 4 by y factorial plus e power 6 e power minus lambda summation z equal to 0 to infinity lambda cube into lambda power z by z factorial plus 7 into e power minus lambda summation u equal to 0 to infinity lambda square into lambda power u by u factorial plus lambda. Here fourth moment equal to e power minus lambda into lambda power 4 common, then expansion. Lambda power 0 is 0, 0 by 0 factorial is 1 plus lambda power 1 by 1 factorial plus lambda square by 2 factorial plus so on plus 6 lambda square, 6 lambda cube e power minus lambda. Again apply the 0 to infinity 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus so on plus 7 lambda square e power minus lambda. Again apply u 1 plus lambda by 1 factorial plus lambda square by 2 factorial plus so on plus lambda equal to e power minus lambda. This is nothing but lambda power 4 e power lambda plus 6 lambda cube e power minus lambda. It is the e power lambda plus 7 lambda square e power minus lambda into e power lambda plus lambda. E power lambda minus lambda get cancelled. It is equal to lambda power 4 plus 6 lambda cube plus 7 lambda square plus lambda. It is the fourth moment. Therefore, fourth moment is equal to lambda power 4 plus 6 lambda cube plus 7 lambda square plus lambda. These are the four moments about the origin in Poisson distribution.